Okay, this example looks interesting. It says kinetic energy is a kind of energy that is stored in the motion of an object. The kinetic energy of a small object of mass m and velocity v measured in joules is determined by the formula, and they give us this formula. Blah, blah, blah. We don't really need all that. Suppose that a small object of mass zero point 0.1 kilograms is freely falling, assuming downward acceleration of 10 meters per second squared. At what rate is the kinetic energy of this object changing when its velocity is 180? Wow, that's a lot. So notice they're asking for E prime. So let's bring down the E formula, huh? So E equals 1/2 mv squared. Okay. That's energy, it's kinetic energy. If you take physics, you'll use this formula, 1/2 mv squared. So they want E prime. So clearly we got to take the derivative. So let's do that. So derivative this side, derivative that side, derivative both sides, right? So, but now realize this is going to be the implicit derivative of both sides. Why? Because we're taking it with respect to time. How do I know that? Because we want at what rate is energy changing? So, oh, it even has a T there. So really what I'm doing is I'll show both Leibniz notation and Newton's. DDT. You don't have to write both. I'm just being over the top. We're doing DDT. We're doing the difference in energy over time and the difference in this equation over time. So my point is this E is different than T and V is different than T as well. So therefore, we've got to do implicit. Implicit different derivative is when the letters top and bottom and the derivative top and bottom are not the same. And they are not the same, right? The D, E, and T are not the same. The D, V, and T are not the same. All right, enough said. Let's get going. So what do we got? E prime equals. Now, do you realize that 1/2 and m are just fixed numbers? Now, you might think, I got the half, Heron, but what about the m? Why is the m fixed? Well, what is m? It's the mass of the object. That doesn't change, right? The object's not getting heavier or lighter. It's just a whatever it is, and they're going to tell us what it is in a minute somewhere. Oh, here it is, 0.1. It's not changing. It's just going to stay that. So just leave that. So the 1/2 an m, that's just a constant number sitting, multiplying in the front. Now the v, though, the velocity, that's not velocity. The velocity of the object is changing. Why? Because what are they saying is happening? It's freely falling. So we're measuring what happens for a small object that's been let go from from the window of an airplane or the top of a cliff or outside the window of a building. It's freely falling to the ground. So the velocity is going to be changing. It's going to be speeding up, right? Whereas the mass isn't changing, but the velocity is. So that's my variable. So the two is going to come on down. So you got to be clear which letters are actually changing. Their variables are going to vary. Which letters are just fixed. The mass is not changing. All right, so bring down the 2v, and subtract 1 from the power, so it's v to the 1. But that's not it. Times v prime. Because again, it's the implicit derivative, right? V prime really means dv dt. So just like we learned earlier. All right, let's keep it going. So now E prime equals, in fact, actually, you know what? Why don't I write, I mean, E prime is good, but why don't I actually write in dE dt and I'll make this dV dt. That's what it really is, right? It's the change in energy over time. It's the change in velocity over time. Okay, so come on down. You don't have to do that, but I'm just trying to be really clear. So, all right. So it's a half. Now it's time to plug in m. I think the mass is 0.1. Put that in right there. Times 2 v, velocity. They gave us that somewhere right here. Velocity is 180. Boom, right there. 180. Now here's one of the trick parts. What in the world is dv dt? dv dt, or v prime, however you want to say it, is change is the derivative of velocity. Now, you might say, yeah, okay, yeah, I got that. It's v prime, so it's derivative of velocity. Yeah. Remember earlier in the course when we had like s, which is the position of some object, v, which is the velocity of the object, and a, which is the acceleration of the object. And we found that these guys were related by what? By taking the derivative. Remember that? Because, you know, the position, like if my car is just sitting in the driveway right now, whereas if I start driving my car down the road, that'll become velocity. That's how fast the position of my car is changing now at maybe 10 miles per hour, right? I'm going real slow down the road. So every hour, the position of my car moves by 10 miles, right? That's the derivative. It's got 10 miles on the top over 1 hour on the bottom, right? But and then if you take the derivative of that, you get acceleration. Like if I take my car from 0 to 60 miles per hour in a certain amount of time, that's change in velocity. We call that acceleration. Okay, so long story short, my point is V prime is what? Acceleration. V prime's acceleration. V prime or dv/dt, either one, is acceleration. It's because it's the derivative of velocity, right? Position, the derivative of velocity, take another derivative. That's acceleration. So acceleration is the derivative of velocity. So v prime, derivative of velocity, is acceleration. And that they told me right here. Acceleration 10. That's this. That's the 10 right there. You see. So that's the trick. They want you to recognize that's what that is. All right, we got it. Hit the buttons on your calculator now. So D, T, yeah, just hit those buttons and you will get the answer. And it comes out, is that 180? Yeah, it is. It's 180. There we go. They've already got the units for us. That's how fast the energy is changing. And so there we go.